Happy, what day is it? I don't even remember. Halfway through the weekday today. Who knows when you'll be watching this? But I hope everybody's doing well. We are moving on from factoring, so that's very sad. However, we're looking at rational expressions, which is pretty exciting. The other thing is you still get to factor when we're looking at rational expressions, which is also very exciting. So don't be too sad. So first thing that we need to do is to kind of figure out what a rational expression is. So it's just an expression whose numerator and or denominator have polynomials. Okay, so an expression whose numerator and or denominator has a polynomial in it. So we want to make sure that we have simplified rational expressions. So this is when the numerator and denominator have no factors in common other than 1. Okay, so to do this, we do have to remember some of our exponent rules with division. So just as a quick review, when you're dividing exponents that have the same base, right, you keep the base and then you subtract your exponents. Okay, so we have to remember our exponent rule here with dividing. Okay, so again, quick review here. If we were to simplify this problem, right, the coefficients, 3 over -9, we just simplify to -1/3, x to the third, and x to the 0. X to the 0 just becomes 1, right? So this just becomes x to the third, x to the 0 becomes 1, y to the fourth over y to the sixth. Remember, we subtract the larger exponent minus the smaller exponent, and our trick was that we then put that positive answer where the larger exponent was. So if we do y to the sixth minus y to the fourth, we get y to the second, and we put the positive exponent on the bottom because that's where our larger exponent was. Okay, just another quick review problem here, number 2. If we simplify inside our parentheses first, so we would have 2/3 x to the third over x to the first. So we subtract that to get x to the second. Y to the fourth over y to the first, we subtract to get y to the third. Okay, and this is all to the third power. So 2 to the third power is 8, x to the sixth, y to the ninth over 3 to the third power would be 27. Okay, so again, quick review there. This is so fun. You have exponents and you have factoring. Pretty good. All right, so a common mistake that people make that you want to make sure that you do not do is if you have like x plus 3 over 3 and you're asked to simplify that, people will cross off the 3's here and make it x. You cannot do that, okay? So no. Okay, do not do it. Okay, so for example, it says try it with numbers. Like let's say we put in, 2 for x, so 2 plus 3 over 3. We couldn't just cross off the 3 and have it equal 2, right? Because if we actually tried it, 2 plus 3 over 3, we'd get 5 over 3, which does not equal 2. Okay, so the same thing is true here. X plus 3 is a factor that's all together. You cannot just cross off the 3's. One thing that is sometimes helpful is people will put parentheses around the binomials, right? So x plus 3 is a binomial. You could put parentheses around there so you know it can't just cancel the 3's out. It would have to be another, like x plus 3 on the bottom to cancel that out. Okay, so for part 1 here, the first thing that we're going to do when we're simplifying, you always want to put your polynomials in standard form, and then you're going to factor them if you can. Then you're going to cancel out common factors from the numerator and denominator. So for example, number 5, the only thing that we can factor out here is we can take out a 2 from the top and a 2 from the bottom. This is different than what we just did, the common misconception up there. because it's connected by multiplication. It's not 2 plus x, right? It's just 2x. So you could take a 2 out of both of those. So we'd have x over x plus 5. And again, do not cancel your x's out because x plus 5 is a binomial. So you could only cancel that with another x plus 5. Okay, so for number 6, first thing that we want to do is in standard form. So we're going to factor anything we can. So we could factor out a 12 from the numerator to get 2x plus 1 over 3. Okay, and now we could take a 3 out and make this 4 and then 2x plus 1. Okay, and again, the 12 and the 3, we can simplify those because they're connected by multiplication. It's not like 12 plus 2x. Okay, so for number 7, we want to put this in standard form on the top. So I'm actually going to, well, let's see, if we put it in standard form, it would be negative x plus 3 over x minus 3. Okay, so if you're trying to think about how you could simplify that, we could actually pull out a negative 1 from this x, negative x plus 3, and that would actually make it x minus 3, right? If we distributed this back in, it would be negative x plus 3. Okay, so this now allows us to simplify the x minus 3 over x minus 3, and then we just get an answer here of negative 1. Okay, so you always want to look for that to see if you can like take out a negative 1 to make them the same thing. All right, number 8, hopefully we don't cancel out the 4's, right? Don't do that, okay, because x plus 4 is connected. So we actually can't simplify this anymore. This is our answer. Okay, same thing with number 9. X plus 5 is a binomial, or yeah, x minus 1 is a binomial. Okay, so we cannot do anything with that. That is also our answer. All right, number 10, we can factor the numerator here to get a 4x plus 3. And then on the bottom, we just have x plus 3. So now we can cancel out these binomials and we're just left with 4. Isn't this fun? Because you still get to factor and now you get to simplify. Oh my goodness. All right, number 11, we have a trinomial, right? This is an easy trinomial because there's no coefficient in front of the x squared. So we're just looking for what multiplies to 3 and adds to 4. Okay, so 3 and 1 multiplied to 3, add to 4. On the bottom, we're going to take out a GCF of x, so we get x plus 1. And then our x plus 1s are going to cancel out. We have x plus 3 again, which is a binomial, so don't cancel out this x and this x. Okay, so x plus 3 is connected. You cannot just cancel the x's out. Number 12, we're going to rearrange the bottom here to put it in standard form. Okay, also in the denominator, you can take out a 5. I'm going to take out a negative 5, so it's 15x over negative 5, so I can make this a positive 2x minus 1. So again, you always want to try to make that first term positive. I'm going to take out a negative 5, and then now I can simplify the 15 and the negative 5 here. So that would give me negative 3x. Okay, so negative 5 goes into 15, negative 3 times x, and then 2x minus 1. And again, the reason you can simplify 15x and negative 5 is because 15 is connected to the x by multiplication, not addition or subtraction. All right, number 13, another easy trinomial because there's no coefficient except for 1 in front of that. So we know it's x plus 3 multiplies to 9, adds to 6. We're going to rearrange the bottom here. And again, I'm going to take out a negative 1 so that I can make it x squared minus 9 because now I get to do dots. Okay, if we left it as negative x squared plus 9, you can't do anything with that, right? So you would, well, you could still do dots, but then you'd have to still take out a negative 1 so that you could cancel out one of these factors. Okay, so always look to factor out that -1, and then your answer here is x plus 3 over -1x minus 3. All right, number 14, again, easy trinomial on the top there. So what multiplies to -4 and adds to -3? So x minus 4, x plus 1, right, multiplies to -4, adds to -3. And then on the bottom, what multiplies to 36 and adds to -13? So if you're not sure, just start going through, right? So 2 times 18, 3 times 12, 4 times 9 is going to be what works. Okay, so again, if you're not sure, you can always do this chart to kind of figure it out. So it's going to be x minus 4, x minus 9. That will multiply to a positive 36, add to a -13. We can cancel out our x minus 4, so we're left with x plus 1 over x minus 9. All right, last one of these here. We have a tricky trinomial on top. So what multiplies to 12 and adds to 7? So 3 times 4. Okay, so for our tricky trinomial, remember we have to do 3x plus 4x plus 6. Oh, those are t's. Well, I'm going to make them x's. Okay, so we take out a x to get 2x plus 3. We take out a 2 to get 2x plus 3. So the top becomes x plus 2 and then 2x plus 3. Okay, so that's for the numerator. The denominator, luckily, is just an easy trinomial. What multiplies to 8 and adds to 6? And I'm just going to make them all x's here. So 4 times 2, right, multiplies to 8, adds to 6. And we can cancel off the x plus 2 and the x plus 2 to get 2x plus 3 and then x plus 4. All right, so those are all just simplifying. The other thing that you're going to see is they're going to say, like the rational expressions are undefined. They're going to say what value makes it undefined. So it's undefined when the denominator is 0. Okay, so for example, it says what value makes the original rational expression undefined. So this first one should be easy, right? So when x is equal to 0, this would be undefined because 5 would be divided by 0. Okay, the second one, x minus 7, we're going to say when x is equal to 7, it would be undefined, right? Because 7 minus 7 is 0. If it's something more challenging than that, right, you just set it equal to 0. Okay, so you set the factor equal to 0 and solve to get your answer of x equals 7. Okay, if you have something you can factor, you're going to do that first. You don't even actually need to worry about the numerator. So you're just going to go through, this is an easy trinomial, what multiplies to -20 and adds to -1. So -5 and x plus 4. Okay, so I don't need to worry about the denominator. I know that if x is equal to 5, I get a 0 on the bottom. If x is equal to -4, I would get a 0 on the bottom. Okay, and sometimes you might see this as x cannot be 5, x cannot be -4. Okay, so either way is fine if you want to write, x is 0 because that would make it undefined. If you want to write it cannot be 5, it cannot be -4. All right, same thing with 19. I am going to factor this first. So take out an x to get 4x squared minus 1, which gives me 2x minus 1, 2x plus 1, and an x. You don't even need to worry about the numerator. That doesn't matter. Okay, so I know that if x is equal to 0, that would make the denominator 0. I know that if x is equal to 1/2, that would make it 0. I know that if x is equal to -1/2, that would make it 0. Okay, so x cannot be 0, cannot be -1/2, it cannot be +1/2. Last one here, okay, multiplies to -15, adds to 2. So +5 and -3. So I know x is not 3 and x is not -5.